All right. So we are going to find we are going to analyze rational functions. The main things you'll want to find with rational functions are their vertical asymptotes and their horizontal asymptotes. This is the main feature on the next test. That's like mainly all I'm asking for. It might be the only thing I ask for. So, how do you find vertical asymptotes? Well, these vertical asymptotes occur when the x values are undefined, and this is because they make the denominator equal to 0. Yep. So to find these vertical asymptotes, we just gotta factor the denominator, if possible, and set each factor equal to 0. We solve for x, and the number which makes the denominator equal to 0 will be the vertical asymptote. You write it as x equals that number because that will be the equation for vertical line. This is drawn as and it's a vertical asymptote, so it's a vertical line. All right, let's do 3 quick examples. Bing, bang, boom. All right, you want to be a part of my video? You can help me out here or not. But yeah, if I had to, quote unquote, factor this denominator, there's not too much to factor. There's a greatest common factor I could probably take out of both of these. What would that be? I know that Alex Gilmer already knows. Yeah, 4, 100%. I might pull out -4 just because that's my style, if they're both negative. But that would be x, and then divide that by -4 would be +4. So if you factor the denominator like this, then what makes this factor equal to 0? It'd be -4, right? And -4 plus 4 would be 0. And you could confirm that. -4 times -4 minus 16, yeah, that'd be a 0. So x equals -4 would be your one and only vertical asymptote, which I'm going to abbreviate VA. Boom. All right, here's one that I'll probably have just like this on the test. It's a basic quadratic. Can you factor this? If I draw 2 parenthesis sets, and I know that it's got to be x times x, what multiplies up to 3 but adds to 4? Probably 1 and 3, 100%. Both positive. Now the asymptotes would be whatever make each of these equal to 0. So they would be -1 and -3. Exactly. Is my vertical. What the heck? I wrote upside down A. My vertical asymptote. All right. Last one's easy enough, but again, I would advise taking out the greatest common factor first. So these both share a 3 and an x, G, C, F. So if you factor the 3x out, then this becomes an x squared minus 9. I'm just going to cut to the chase and do that. So what makes each of these equal to 0? This is where it's a little trickier. What makes 3x equal to 0? Don't overthink it, but this counts as a factor. So what makes 3x equal to 0? -3? No, not quite. -3, by the way, will make this equal to 0. But what just makes this term equal to 0? It's just 0 itself. Yep, it's just like when you have that x in front, just 0. But Peyton, you're right, though. For this one, what would make this equal to 0? Hopefully y'all could solve this and find 3, right? X equals 3. 3 squared is 9. 9 minus 9 is 0. But also -3. So be on guard for the positive and the negative, especially if there's like a squared minus term like that. Boom. There we go. That's vertical asymptotes in a nutshell. It's that easy. Boom. All right. Horizontal asymptotes. They are the ones that fall into these 3 different categories, and that's because they're more of a measure of what the polynomial does as you go really far to the left or really far to the right. It's almost like the end behavior. I just said polynomial. I misspoke. Rational functions. What the rational function does is you go really far to the left or right. Okay, so we got 3 cases. Here's case 1. The numerator is a higher power than the denominator, so bigger power on top. In this case, like in this example, it's like x squared over x. There is no horizontal asymptote. So if I asked you what's the horizontal asymptote, you'd say there is none. Or if you want, you could say it's slanted, because as we'll learn later, that means it's a sine asymptote. I'll just put none for now, though. There's none. There is none. There is no horizontal asymptote. If the numerator is equal to the denominator, if the power in the top is equal to the power in the bottom, if they have the same degree in the numerator and denominator, then this is actually the rare case where you'll take the ratio of the leading coefficients. They write this as y equals a over b, where a and b would be the leading coefficients respectively. But I'll just use this as the example. So the power on the top and bottom is both 1, right? X to the power 1, x to the power 1. But then we just take the ratio of these leading coefficients. So 7 and 1. So the horizontal asymptote is 7 over 1, or just 7. This is kind of the most interesting one because you actually do a little bit of math. And then the last one, the last case, if the numerator power is lower, if the denominator's got the bigger power of x, then it doesn't matter how much bigger. It could be bigger by 1, bigger by 100. They all have the same horizontal asymptote, and that's y equals O. Just kidding, it's y equals 0. It's just as easy as that. It's just 0. So, what are the horizontal asymptotes of these functions? Which case do we got here? The power is the same on the top and bottom? Yep, so that means that for this one, it's kind of the middle case, the ratio of the two leading coefficients, which in this case is 1 for both of them. So 1 over 1 would be the horizontal asymptote, which is just 1. So y equals 1. That's your horizontal asymptote. For this one, the higher power is in the denominator. So it's the second case. So it's just a flat default. It's the big O, 0. And then lastly, for this one, the power is the same in the numerator and denominator. So it's the ratio of 4 to 1, ratio of these coefficients. So y equals 4. I'll put 4 over 1, which is just 4, of course. And that's that.